Bismillahirrahmanirrahim. Hi, my name is Miraj Sayed, and I recently wrote a blog post for Islamic Law blog in which I documented an experiment that I did. And the experiment was, can we search for a canon in a corpus of Islamic texts and find an author citation of the canon even if it doesn't match identically. And basically what this video does is it walks you through the Jupyter notebook that I created in order to, in order to test this experiment out, to see whether or not this was possible. So what do you need in order to actually follow along and do this with me? Well, the first thing you need to do is you need to have installed Jupyter, the Jupyter implementation of Python. You can find information on how to do that here. Anaconda is the company that has created the Jupyter notebook version of Python. So you need to follow their instructions, download them. It's open source software, it's free, so you should be able to do that. And then where can you find the actual notebook itself? I've published the notebook in my GitHub page. You can find that in this particular, on this page. The other thing you need to do, and this is probably the most difficult part, is in order to replicate the experiment and modify it and extend it, you actually need to get access to the Google Cloud service that I used in order to actually calculate the similarity score between any two pairs of texts. The particular Google Cloud service that I used is right now just experimental. And so you need to apply to get accepted into that. And the good side is because it's experimental, it's free. The bad side is because it's experimental, you need to actually apply and justify how you would use it. And then they will allow you experimental access to it. Now, how can you do that? Well, if you go to AI Workshop, Google's AI Workshop, they have a registration page, and what you want to do is you want to apply for Semantic Similarity for natural language. That's a particular service that I applied for and got accepted. And once you get accepted, they're going to tell you exactly how you use their service. You need to create a Google account. You need to have a cloud. You need to have cloud account, a Google Cloud account, and you need to do all kinds of things in order for you to get set up on that end. Now, even if you don't have access to Google's Semantic Similarity cloud service, you can still, see how I get access to the Islamic legal text and clean it up and divide it up and partition it in order to actually get the semantic similarity scores. So let's just dig in. Here is the Python notebook that I created, and it's divided into basically three main sections. The first section is just how do you import in an easy way a particular Islamic legal text from OpenITI. And I'll talk a little bit about what OpenITI is in just a moment. The second section is how do you prepare this Islamic legal text for semantic similarity processing, which also for our purposes involves locating a particular chapter within a given text. And then the third section is sending the fragments, sending the two texts that you want Google's cloud service to compare and to quantify the similarity of. and then how do you record the results, basically. All right, so let's begin. Let's assume that you have the Jupyter Notebook up and installed. That in and of itself took a lot of wrangling. And actually, before I start, let me talk a little bit about my own background. Like, how familiar am I? I actually do not have formal training in computer programming and coding. I ended up teaching this to myself just because I was interested in seeing whether or not there were any computational and digital techniques that we can apply to research problems that I'm interested in that will make my job a lot easier, that will enable me to ask questions that I'm not capable of answering without using those techniques and things like that. So, I don't necessarily have formal training. I kind of just, picked this stuff up through a little bit of research. Let me just say this. Microsoft has recently published a series of learning modules on, I believe they're available on YouTube, that and each video is like 2 to 3 minutes long, so it's very easily digestible, that describe you the basics of the Python language and how you can do some very basic stuff. That might be a pretty good resource for you to consider looking into. So let me just walk through the code. So you've downloaded the Semantic Similarity Evidence Canon Kitab al-Shahadat Jupyter Notebook. You have it, you've installed Jupyter, and you've brought up this particular notebook. This should be what you're seeing, or something very close to it. So the first thing that we need to do is we need to get an Islamic legal text from OpenITI. Now, OpenITI has collected, thousands of Islamic texts, and they've organized them in a very neat way, and they've standardized the way that the texts look, and they have annotated. They have done a lot of useful annotations of these texts. So check them out. They have been around for a couple of years now. I don't exactly know how, and I think that the work that they've done is amazing, and actually needs to be, I think, engaged. The scholarly community needs to engage their work and use their work. Here is their GitHub page, and you can see that they've divided up their texts into 75-year segments. Now, it's actually quite difficult to find text that you're looking for through the GitHub page. What they've done is they've created a useful tool which allows you to search for texts through various categories. So, for instance, if you wanted to look for Qarafi's text, he was a 13th century Maliki jurist, very famous, very influential. You can just search and it will bring you all of Qarafi's texts. Not all of them, the ones that they've digitized, which seem to be, pretty good number. So this is a good way of figuring out what text that they have. The thing that you need to look for is the particular. All right, so this is a good index, good catalog of texts. So what do you do now? Well, you need to get the URL of the text that you're interested in. Now, we are interested in Qarafi's Dhakhira, right? And the particular, now, when you look at Qarafi Dhakhira, you actually find that there are two versions. One version right here, which comes from Al-Jami al-Kabir, another version that OpenITI has taken from Shamila. Now, the particular version that we're interested in, and I talk a little bit about this, why this particular version is the one that was more useful for our particular project. Is I talk about this in my blog, is the one that originates from Al-Jami al-Kabir. Now, this is the raw data. This is actually what that particular text file looks like. Your browser can open it up and you can very quickly see what are its contents. But what we're interested in is not the content itself for our purposes, but actually the URL. So if you do a copy and paste, that's where I'm getting the URL in the book URL. All right. So we know the URL of the book. How do we get the contents of that of Qarafi's Dhakhira into a variable, which we can then further manipulate in a variety of ways? Well, the way to do that is, the first thing we need to do is we need to actually import what's called a library that allows our Jupyter Python notebook to request and get the text from OpenITI's GitHub repository. And the first thing we need to do is we need to import that library. Now in Jupyter Notebooks, the way that the interesting thing about the notebook format of Python is that you can enter in a command and you can very quickly see whether or not that command worked or didn't work. And for that reason, it's actually quite a useful tool to explore and to basically write scripts ad hoc, and to very quickly find out what works and what doesn't work. All right, so you type in import URL lib.request, and then you press you have your cursor at the very end of there, and then you press shift and enter, and you see that the input now has a number next to it. That means it's processed it, and as long as I didn't get an error message, I should assume that it's working fine. All right, so we haven't actually done anything yet. Now what I do is I put the contents, put the URL, which is a location on the internet that has the text, into a variable, right? Book URL, and I pasted that variable in that URL into this variable, and then I do a shift enter, and now book URL contains that particular address, the address. How can we check that? Well, let's how can we be certain that in fact book URL contains the URL? Well, one of the ways we can do that is we add a cell, what's called a cell, and if you type book URL and put enter, shift enter, it will return to you what is the content of that variable, and you can see that it has in fact recorded the particular URL that I wanted it to record. All right, so now what I'm going to do is I'm going to ask the Jupyter Notebook to use the URL library that I imported into it, and to go grab the text from the URL library, and this is the command that does that. So press shift enter, and you can see the star right now. That means it's thinking, it's processing it, and then when a number comes back, it tells you that it has accomplished that particular task, and if we don't have an error message, you can assume that it's done it well. Now, okay, so we went and we retrieved the content of the khira from OpenITI's GitHub page. And one of the ways that we can check whether or not we have something in our book underscore text variable is to do what's called a len function on the variable book text. And what that returns is a number that tells us that how long or how large the contents of the book text variable is. So let's go here. Let's do a shift enter, and you see that it gives us the Jupyter Notebook returns a value 6,646,807, and what that refers to are the number of characters that compose the book text variable. And in fact, we can look at inside book text and give Python a range of characters that we want to look at, and it will display them to us. So let's look at the first 100 characters, and what we'll see is, in fact, there's stuff there. And in fact, if we go and compare the output of the first 100 characters in book text with the raw data that we see, you can see that there is, in fact, a lot of overlap. That the only difference is that the raw text here has tabs, it's organized, it looks neater. There are each of the relevant lines, there's an independent line, they're separated on our screen. And it actually is the case that there are lines separating these characters as well, but they're just not shown. The \n indicates a new line. And in fact, that's actually going to be an important thing that we need to remember, because we're actually going to use the new line character, which is what it's called, in order to partition the text, in order to partition the khira. All right. So if you had read my blog post, you will have known that, in fact, I tried to partition the entirety of Qarafi Dhakhira, all 6 million characters, into paragraphs, and I tried to send all of those paragraphs to Google's Semantic Similarity service, but eventually that didn't work because many of the paragraphs were too big. And I also thought that maybe the book itself is too big. So what happened was that, well, how can we scale this back while at the same time trying to test whether or not semantic similarity can actually discover the citation of a canon? What we decided was that with consultation with Dr. Rub and Dr. Shaybani, that, you know what, we're going to look only at the testimony chapter and the criminal law chapter. We're going to look at the testimony chapter and we're going to try to see whether or not Qarafi cites the evidence canon. And similarly, when we look at the criminal law chapter, we're going to see whether or not Qarafi cites the doubt canon. And what this notebook is just one of those two books. We're going to look at the chapter on testimony, and we're going to see whether or not we can discover the evidence canon. All right. So one of the immediate things is, well, how do we, Islamic legal texts, positive Islamic legal texts, fiqh texts, are divided into chapters. How do we find the testimony chapter, and how do we remove the testimony chapter and put its contents into a different variable that we can then partition, and then that we can then send on to Google Semantic Similarity service? Well, one way to do that, typically speaking, is through looking for chapter headings, right? Every single fiqh book is divided into chapter headings, and usually it's preceded by the word kitab, kitab al-tahara, kitab al-shahadat, Kitab al-Jinayat, and in fact, that is exactly the type of structure that exists in al-Jami' al-Kabir's version of a dhakhira found on OpenITI. So in order to search for all of the instances of chapter titles in the dhakhira, we need to download a different library called regular expressions. And regular expressions is this really neat tool. It's a very powerful and flexible tool that allows you to use all kinds of wildcard characters to search in a flexible way for all instances of a phrase, of a word, of a character in a text or in a string. I mean, it's technically called a string. So that's exactly what I do in this in the beginning of this section. So I import RE. RE stands for regular expressions. Download this library so that my Jupyter notebook can use it. And then what I do is inside the quotation is the pattern that I'm searching for. And the pattern that I'm searching for is partly based on the chapter titles that the editor of the dhakhira used, kitab followed by whatever the kitab is about. But what OpenITI has also done is it has indicated sections by using the following convention. It basically says pound, space, pipe symbol, space, open, parentheses, kitab, followed by at-tahara, ash-shahadat, jinayat, whatever, right? And this thing in the single quotations is that pattern that I'm searching for, right? So I do a shift enter on that, and then I basically tell Python, hey, I want you to find all instances that in the book text which matches this pattern, and put the results of that into a new variable called title instances, right? So we do that. Okay, how do we know whether or not there is actually content in the title instances? Well, we can do one of two things. One, we can do a len command just like we did with the book underscore text. Another thing is just merely to do a title, just type out title instances, press shift enter, and it will give you a list of all of the kitabs that are found in the dhakhira, right? And what we're looking for is kitab al-shahadat, and it's right here. And if you counted from 0 all the way to kitab al-shahadat, you would find that it is the 31st item, right? Well, how many items or how many elements are in title instances? There are 44. There are 44 instances. And if we say, hey, I want to just see the 31st instance and see whether or not it is in fact kitab al-shahadat, well, we can do that here. Do a shift enter, and you see that it is a kitab al-shahadat. So now we know that we can search through the dhakhira, which is in the book underscore text, right? Variable. Find kitab al-shahadat, and we know that's where it begins, where the kitab al-shahadat begins. And we know that the chapter title after kitab al-shahadat is kitab al-watha'iq, and that's going to be title instance number 32. So basically, we know that logically, the substance of kitab al-shahadat is between these two title instances, title instance 31 and title instance 32, right? And let's just see what title instance 32 is, and you'll see that in fact it is kitab al-watha'iq. Here we go. We got an error. Why is that? The name title instance is not defined. That error basically means there's no such a variable named title instance. That's because it's title instances with an S. And there's Kitab al-Wathaiq. All right. So we know, logically speaking, where the beginning and ending of Kitab al-Shahadat is. Well, how do we go about and locating that content and putting it into its own variable that we can do further operations on? What we need to, before we get to that step, we need to do another intermediary step. And now this notebook's looking super clean, right? Everything flows logically well and things like that. The actual trial and error of figuring out this is the right order, this is what I need to do, what are the commands that work, what are the commands that don't work, took many hours. So what you're seeing is something very, very clear, not very clear. I'm sure that, professional coders can do a lot better job. But it's clearer than, the rough draft that I used to develop this procedure. And oftentimes I have to remind my students, like, when we do a reading, it's like what you're reading is the end product of many people working together to polish it up. And something that has gone through many, many drafts. So do not expect your own rough draft to be as polished as what you're reading. And oftentimes I find my students can find comfort in that. In fact, I find comfort in that. All right. What we see is when we go and we look at the raw text, we find that each line is composed of like 10 or 15 words, right? And a new line is followed by these tildes. And I talked about this in my blog post as well. What we want to do is eventually we want to, and the reason why OpenITI did this is that they kind of artificially introduced new lines because it's just easier to read 10 words at a time. And if they didn't have new lines that separated out each 10 words, then it would have been much more difficult to read because if you opened it up in a text editor, you would have all of these things would have been one huge giant line that's not really readable. So they introduced these two tildes as a artificial convention to help people read them. But for our purposes, we actually need to get rid of them, because what we're going to do is we're going to get rid of all instances in which a new line is followed by two tildes. And when we do that, we are going to have what are basically paragraphs. And once we have paragraphs, then we can partition the dhakhira into paragraphs based on whatever new line characters remain in the book underscore text variable. So how do we do that? Well, we've all done search and replace. Maybe not all of us, but a lot of us have done find all and replace all operations in Microsoft Word, Excel, and Google Docs, and that's essentially what we're doing, but we're doing it in Python. And basically what we're saying is, hey Python, I want you to look inside this variable, and I want you to run this command, the replace command. And I want you to find all instances in which there is a new line, right? And that's how you indicate a new line, and two tildes. And I want you to replace it with a new line and one tilde. A space, I'm sorry, not a new line, a space and two tildes, right? And then once you've made that transformation, I want you to put the contents of this new transformed text into a new variable, which I call book text prep for paragraphs. And the reason why I'm putting it into a new variable as opposed to just putting it into the old variable is because sometimes you make a mistake and you don't want to go back and have to, for instance, re-download from GitHub the book. So a lot of times it's good practice to just create a new variable, because then the new transformer context is going to be in book text prep for paras, and book text is going to remain as it was before the replacement operation. So, that's good to do. So let's do that. Okay, so we've done the search and replace. Now what we need to do is we need to split the book into paragraphs. And since we have gotten rid of the unnecessary new lines, we can do that now. So, and this is the way that you do it. Basically, regular expressions has a function called split, and basically it will say, hey, take the contents of book text prep for paras, and I want you to split that every time there's a new line and put it into book text para. And that's what it does. It splits it, and then book text para is now a list of paragraphs. So let's, well, how many paragraphs are in book text para? 7,625. What does the first one look like? Let's see. Oh, don't want to do that. What you will find is one line. There you go. Right? What if we did 1,000? What does the 1,000th paragraph look like? What does the 2,000th paragraph look like? 2,500. So what book text para has done is partitioned the khira into 7,625 paragraphs. Now, how does this relate to? We need the testimony chapter, right? Well, there is this very interesting command called index. So basically, we take the book text para variable, and then we apply the index command to it, and we say, hey, listen, the contents of title instances 31, which is Kitab al-Shahadat, where exactly, in which element does it exist? That's what we're trying to figure out, right? So if you press enter, it will say, hey man, it's 5,384. So in the 5,384th element, you will find Kitab al-Shahadat. Okay. So if we go into book text para, 5,384, and that is exactly what we find. Similarly, now we know that Kitab al-Shahadat indicates the beginning of a dhakhira. What indicates, Kitab al-Shahadat indicates the beginning of the testimony chapter. What indicates the end? Well, it's going to end when the next chapter begins, which is the 32nd instance, the 32nd element in the list title instances, which is Kitab al-Wathaiq, which is 5,714, right? And if we look at book text para, 5,714, we will find that I used I used parentheses instead of square brackets, and that's the error I got. Kitab al-Wathaiq. So we know from 5,384 to 5,713. Those are all the paragraphs that belong to Kitab al-Shahadat. Right? So let's put those paragraphs into its own independent variable, which I called Kitab al-Shahada text para. Right? So I basically say, I want you to place element 5,384 to element 5,713 into its own new variable, right? And that's what we do. Okay. Now, eventually what we want to do is we want to divide up the Kitab al-Shahada into 20 gram fragments. All right? That's eventually what we want to do. In order to do that, we have to get 20 gram fragments. And if you want to know what an n-gram is or why that is that we wanted to do that, go and read my blog post. Before we do that, we need to do two things. We need to remove and clean all of the extraneous punctuation marks, hashtags, pipe symbols, parentheses. Remove them because they are going to get in the way of getting good similarity scores from Google's service, cloud service. And this is actually quite an important step in many natural language processing related tasks. Getting rid of any symbols that might interfere with doing a semantic similarity task, for instance. All right, so how do we rejoin the text that we have segmented into paragraphs? There's this join command, and basically what this command does is it takes the contents of Kitab Shahadat text paragraph, which is a list, and it says join all of the elements in the list, but I want you to separate each element of the list, which is a paragraph, by a space, right? So if I had, and I do this, that's what's going to happen. And so, for instance, if I did a len command on Kitab Shahada text, it's going to be not 5,713 minus 5,384. It's going to give me all of the characters that make up Kitab Shahada, right? Okay. If you want to see it, let's take a look at that. I don't want to do that. So, for instance, the text. So the Kitab Shahada text is composed of 230,029 number of characters. All right. Okay. So now we've rejoined it. Now we need to remove all of the extraneous punctuation, Latin characters. How do we do that? Basically, we want to get rid of everything that is not Arabic, essentially. Any kind of symbol that's not Arabic, we want to get rid of it. Because we saw that, in fact, OpenITI has annotated all of their texts with, there are some English characters in there because that contains information like publication, date, editor, things that they introduced in order to keep track of their types of files in order to help us keep track. But we need to get rid of that because that's going to get in the way of doing any kind of semantic analysis. So we are going to rely on another library called the counter library. So the counter command is part of a library called collections, and we're going to import that into our notebook. And this is a very powerful command. What it basically does is you give it a string, okay, and it counts all of the frequencies of every single letter or character that exists in that string. So let's do that. So I want to run a counter on the contents of Kitab Shahada text, and I want to place the values that are returned from that into this new variable called letters Kitab Shahada text. Okay. Well, what is inside letters Kitab Shahada text? Let's look at it. And here we go. So spaces, there are 43,998 spaces. There are 329 hashtags, 73 ampersand signs. All the way down, now we start seeing the Arabic letters, right? 10,512, yeah. 1,682 alif maqsuras. 10,092 wows. Okay. What we can do is we can use this information to find everything that is not in Arabic text. And then once we have located and identified all of the things that are not in Arabic text, we can delete them. Okay, so how do we do that? Well, we first need to transform this variable, which right now is a special type of object called a counter object. And we can't directly, at least I don't know how to directly manipulate the counter object, so I need to transform it into something that I can. So what I eventually want to do is I want to just get a simple list. In order to do that, first I need to change this variable into what's called a dictionary. It's a type of data. It's a data type in Python. And then what I want to do is, since I don't really necessarily care about the frequency, I don't care about these numbers, right? I don't care. I mean, those might be useful for some other procedure, but for me, all I want is the letters. What are all of the letters that exist, that occur in Kitab Shahada text? The way to do that is to do this command right here. What you're going to get, let's take a look inside this letters Kitab Jinaya text. And you will see, hopefully, that I have a list of all of the characters that occur in Kitab Shahada. Now I need to get rid of the pound sign. We need to keep the spaces, right? The spaces demarcate words. Need to get rid of the pipe symbol. Need to get rid of this open parentheses. Need to get rid of this close parentheses, at symbol, Q, B, tildes, right? E. Get rid of that. So what I did was I just went through this list and manually, created all of the characters that I need to get rid of, and I put them into this variable called cancel. And this cancel is a list of all of the characters I want to delete. You can see that right here, right? So let's do that. And then what I'm going to do down here is I'm basically going to do another search and replace. I'm going to say, hey man, I want you to search for all of these instances and delete them from the Kitab al-Shahada, right? But before I do that, in case I mess up, I want to take the contents of Kitab al-Shahada, stick it into a temporary variable called Kitab Shahada text 2, and then I'm going to do a search and replace command on the Kitab al-Shahada 2, such that if I mess up, I still have Kitab al-Shahada I could go back to, right? So let's do that. And then, one of the most powerful concepts in programming and coding is the loop, which is, the loop is do one command many times. Basically, in Python, the loop, one form of the loop command is called the for command. And basically it says, for every character in the list cancel, right, which I call I want you to delete, replace the I with nothing. That's empty, right? Replace it. So essentially it's a deletion because I'm replacing. And what it's going to do is it's going to, for like, I don't know, there's like 40 something characters. It's going to go through and say, I in the first iteration is going to be the pound sign. And then it's going to go back. And then the second iteration is going to be the pipe symbol, open parentheses, close parentheses, etc., etc. Right? It's going to end up deleting all of those characters. And do that. So how do we know whether or not, in fact, all these characters that we wanted deleted are gone? Well, remember our old friend, the counter? Let's do that. And you will see that, in fact, we have 43,998 spaces, and we only see Arabic characters. Okay, so we have cleaned the testimony chapter, eliminated all non-Arabic characters. Now we're ready to partition it into 20 grams. And the way that we're going to do that is we're going to use import a command called ngrams from the natural language processing toolkit library. But the ngrams command has to receive as its input a list of words and not a string, right? Essentially, what we're doing is we are just manipulating data and changing it, and what we're changing it into is dictated by the type of operation we want to perform on it. And the types of operations that we want to perform on it, the way that those libraries and those modules have been built, they say, hey, if you want us to work, it's got to look, the data you give to me has got to look in this particular, it's got to have this very strict format and structure. And that's essentially what we're doing. So now, because the ngrams command will only take a list of words, not strings, we have to take the Kitab Shahada text 2 and split it into words. And the way we do that is we take that command, we do a dot split, and we basically say anytime there's an empty space, split it, right? And let's see, how many words are there in the Kitab Shahada text? Or I should rather say, how many subsequences of characters are separated by the space? That's really what it is. Well, it's 41,675 words, right? And let's see whether or not, in fact, the first word is a word. Zero. And there it is. That's a list of words. Every single element is a word. Shahida ma'an thalatha lahul arab lisan fi shahida shahadat. Right? Okay. Now the words kitab shahada underscore text is formatted in a way that the ngrams command will be able to do its work. So let's import from the natural language processing toolkit the ngrams command. Okay. And basically the format of the ngrams command is you give it the variable you want the ngrams command to operate on, and then you tell the ngrams command how many gram fragments. Like you want a 20 gram, you want a if you wanted a bigram, it would be 2. If you wanted a 7 gram, it would be 7. If you wanted a unigram, it would be 1. If you want, although it's already unigram, if you want a trigram, it would be 3. We want a 20 gram, right? Okay, so just like last time, the results of applying the counter command resulted in a counter object, and we weren't able to access that until we turned it into a dictionary, and we turned the dictionary into a list. Similarly, the results of applying the ngram command will create an ngram object, which we can't see inside of until we convert it into a list. And that's exactly what we do in this command. And then once it's converted into a list, we can look at what is inside of it. So kitab shahada, for instance, 0 should be a list of the first 20 words, separated by commas, right? And then 1 should be the second list of 20 words. So we can see the overlap if we put in the first 2 elements. You can see kitab shahada shahida fi lisan al-arab lahu thalathatu ma'anin shahida bima'na alima wa minhu qawluhu ta'ala wa kunna etc etc etc, and we can see that there's 19 word overlap. You can see right here, these are the overlap words, right? Kitab has been dropped. Kitab is not the first word, and ala kul has been added. So you can see that that's exactly the ngram concept. All right, so now we have, ngrams that have overlaps of 20 gram phrases, 20 words each, but we cannot feed that list of words into Google, because Google wants phrases in which spaces separate words. So we have to recombine it. So again, we have this theme of transformation. We're constantly transforming the structure and form of the data in these variables based on what further operation command requires that data should look like. So this is a code that basically rejoins the 20-word fragments, the 20 grams, and creates 20-gram phrases, which not separated by commas, not as independent list of words, but as a phrase. And this code does this, and it uses the for loop to do it, right? For every single list of 20 words, I want you to go in there and rejoin each word, put a space between them, put them into a temporary fragment variable, and then I want you to put that fragment into a list. A new list called joined 20 grams kitab shahada, right? That did it. 41,656 20-gram fragments, and you will see now it looks like a phrase, right? So rejoined. Let's do 2. The exact same thing is now a phrase. Okay, so we made a lot of progress. We imported the dhakhira. We have, what else have we done? We have partitioned it into paragraphs. We have located the kitab al-shahada, the testimony chapter. We have created 20 grams of the testimony chapter. Now is a pretty good time to save the contents of this last variable into an external file, such that, because what if something goes wrong, I lose power, my computer gets hung up, I don't want to lose all this work. I don't want to have to have gone through and redo all of these commands in order to get to this place again. So what we're going to do is we're going to save it to an external command, save it to a not an external command, an external file called a CSV. We're going to import the CSV library, and this is the format within which you can write the contents of the joined 20 grams kitab al-shahada right here into the external file. Now, it took me a long time. Like, I did not know Python very well, and in fact, the main computing language, computer processing language that I used was this software called Mathematica. I had been working with that software for, I don't know, 2 to 3 years or so, and I had gotten pretty proficient about that. But the problem with that is it costs money. Python is free. Python is open source. Mathematica is not. So if I was to share a Mathematica notebook with you, you would have had to purchase Mathematica in order to even see what I was doing. So that was not sustainable for public consumption and usage. So that's the reason why I had to switch over to Python. But that also meant it was a steep learning curve. And in fact, I kind of got how I learned how Python deals with things is just through trying to do this project, which is a very long-winded way of saying that if you were to ask me, like, why does exporting a file have to take this particular form? What is the with command? What is it doing? I would not be able to answer you because I really don't know. A lot of this is a black box for me. And the way that I discovered that it works is simply, whenever I had problems, I would just Google it. And I would see what other people had done and kind of just take their code, modify it, see if it worked. And it's really trial and error. Anyways, this should create a 20 gram kitab shahada fragments.csv file, and it should contain 41,656 rows of the 20 gram fragments. Let's see whether or not it worked. Okay, here we go. You can see, there it is. There's Microsoft Excel. It's a CSV. Let's see. Let's open that file up and see its contents. Okay, we have Excel now. We want to import NUTF code. It's delimited. The comma. Now I'm back, and you can see. And you can see how the overlap of the 20 gram fragments work quite clearly. And if you scroll all the way down, right? You will see the last fragment, 41,656. So it's all there. Okay. Now what do we need to do? Now here's where most people are, maybe even the vast majority of people, not going to be able to do this part, because you have to apply for this experimental program that Google AI is enrolling in. They haven't rolled it out as a commercial service yet. You have to have access to their service. You have to have your project accepted, and then only then can you do Section 3. But let's just see what it looks like, even if you can't do it. And even if you can't do it, I think you, especially for those people that don't have much coding experience, at least you got I feel like I'm trying to give you a taste of how this works. That's the reason why I'm doing this walkthrough. It's really for that, for those. That's my imagined audience. All right. Basically, we need to import this library called Google API Client .discovery, right? And this is a library that Google Cloud wrote specifically for this purpose. Basically, they said, hey, listen, if you want to access our cloud services through a Python interface, you need to make sure that you use this particular library in order to do it. So let's import that. It's done. And then what they said was, for semantic similarity specifically, you need to define this code, right? And basically what this code is doing is, within our notebook, it is defining a command called rank candidates. And you're going to call this rank candidates command once it's defined, and you're going to use this particular command to manage the process of sending the Google Cloud Semantic Similarity Service your text pair and receiving their response. And it's all going to happen through this rank candidates command. All right. So let's do that. Well, actually, even before you do this, and assuming that you have, you got your project accepted into Google's AI experimental services, and you got all of that software installed, before you do this, you need to log into your Google Cloud console, and that will give you the security clearance in order to even use this. So I have already done that. Actually, let me make sure that it is working. Okay, I had done that, but my connection got lost because I did it a couple of hours ago, and I just renewed. I renewed that connection, so it should work. Famous last words. All right, so I have initialized this command. We know because there's a number 72 next to it. And then, all right, we have something like, what is it, 43,376 20-gram commands, right? 41,656, right? 41,656 20-gram fragments. We need to send 41,656 20-gram fragments over to Google, along with the canon that we want to search for in those fragments. And we need to receive 41,656 similarity scores. Google says you shouldn't be sending more than 1,000. Actually, it's a lot less than that. Through trial and error, I found that I can send about 200 and reliably get responses back. So how do I define how that happens? Well, here is the code in which I use a loop in order to loop through all 41,656 fragments and send Google 200 at a time and receive their responses and record it to an external file. This right here is the code that does that. Now the input text, al-bayyina ala al-mudda'i wal-yamin ala man ankara, right? That's the canon that I'm looking for. Okay. Basically, output mid is the variable, which is a list, that is going to record the 200 scores that Google sends me. That's what, so I'm declaring that variable and making it empty right here. But what you're going to see is that that variable is going to end up storing the results of the rank candidates command, rank candidates function, right? And when I call this rank candidates function, I'm sending the input text, which I've defined up here. I'm sending them 200 fragments at a time, which is contained in this join 20 grams kitaba shahada variable, right? And I'm basically saying send, you know, this is how I'm keeping track of which set of fragments I'm sending Google and getting scores back in, right? And then here, when I get the scores back, I immediately write it to a CSV file. Let's just see how this works. And basically, I'm telling here, initial, what I'm saying is that what is the initial number that you want to begin with? How many fragments do I want to send Google's semantic similarity service? And where do I want to end? Now, if I was doing all 41,656, the final would be 41,656. Now, I did it this way. Why? Because oftentimes it would time out. Oftentimes, I'd have to restart it. So instead of going in here and changing all of these numbers in all of these ways, I just found it more efficient to just have one place to change it. So let's initialize this. And then let's see if it works. Let's see if it works. So it is in fact working. Current iteration is 0. Basically it has sent the first batch in because, and there you go. The first batch was written to the file because I use these print commands to let me know what is the status of and there we go. It's done. We got 400 scores. So let's take a look. It should be the case that we have 400 fragments and we have received semantic similarity scores for them, and we have recorded those semantic similarity scores in this CSV right here. Bayyina shahada similarity scores. Let's see. There we go. Bayyina shahada similarity scores is in fact there. And let's take a look at let's use Excel to see whether or not that is in fact there. So let's go to insert and go to data. I found it. I'm importing the scores in. And our delimiter was a comma. We made sure that the encoding is UTF-8. Okay, there we go. There's the fragment. There's the score, right? And now we need to sort it. So let's sort it. And largest to smallest. And here we go. Within the 400 fragments that the Google service received, right, it found that this particular fragment had the highest score. Now, this particular fragment probably does not at all contain any idea that is very similar to the evidence canon. And the reason why is because we'd have to go through all 41,656 fragments and then do a sort, and then you'll see the evidence canon actually in fact occur, as the fragment that contains the evidence canon will in fact have the highest semantic similarity score. So, that is how that notebook works. I definitely did not think it was going to take that long for me to go through that notebook, but you always underestimate. I always do. I always underestimate how long things are going to take. I'm always optimistic. My wife's the pessimist of the family. Well, thank you. I hope that was helpful, and it's definitely been an interesting learning experience putting all of this together.